slides, so I don't. If you're printing out the slides, you may just want to check back in to see on my annotated slides. So I made some small adjustments, but this is basically kind of what we had talked. We got a little bit further than this, but this was kind of the main gist of what we had covered yesterday. It was just talking about that big picture of statistics, right? And the idea is that you have some big population that you can't observe for whatever reason. It could be a lot of different reasons. So instead, you'll be taking samples and calculating statistics, and you're going to be working over here kind of in the real world. But the idea is hopefully you'll be able to use that information to estimate the parameters, because those are the things that actually describe the population. You know, so it's like we're trying to predict what's going on here in the big, at the population level by using sample data and statistics and stuff like that. So it's kind of the big picture. Then we talked a little bit about, okay, so you got to go out and actually get data. So we split data into two main categories, which is that qualitative or categorical versus the quantitative. We saw some examples of that. Then this is where we left off. True? Yes. Thinking? Okay. So this should actually, there should be some, if this should say quantitative, because within quantitative data, there are two different types that we sort of distinguish between, because they have to be handled a little bit differently. So like if you go back to the examples we did yesterday, so like if you think about, there's kind of a difference between temperature and number of days per week you work. The nature of those two values is different. Why? Like what's different about the types of numbers or types of values that these two variables can take on?
They represent different things?
Well, yes, they certainly represent different things.
But what is like there's a limit in on one.
One has a limit, right? Like this one has a limit, right? Because it can only be, what can you observe here? Yes, 7 is the most, 0 is the smallest, and you also would only claim like whole number values, right? Like you're going to tell me 0, 1, 2, 3, 4, but as far as temperature goes, what could you record?
Like decimal?
Yeah, you could have decimal values, you could have negatives, you could have positives. There's like almost infinitely many temperatures you could record if your like thermometer was precise enough. Okay, and so those are two different types of quantitative variables. One of them is discrete, and one of them is what we call continuous. And so discrete data, these are quantitative variables which take on values on a fixed interval. And typically that fixed intervals is like the integers, the whole numbers, or, well, really, actually, yeah, not even the integers. The integers can be negative. Usually these are things that can only take on whole number values. So, like the example we just saw is like number of days per week that you work. That's a discrete variable because you would only record 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 of. So for discrete, what would be another example of like a number that you could record about yourself or another person that would be considered discrete, do you think? Well, sort of. So that's a little weird because for continuous, even though like temperature is not discrete, we do have to round it, and we do typically round it. So just because we typically round values doesn't necessarily make them discrete. Because your age technically could be, like, you know, you could be 31.7 or something. Like if you can measure precise enough, you know. But we do normally round and we report it. So age I would actually think of more as the other type, which we'll talk about in a second. But there are certain things that you really can only have like none or 1 or 2 or 3 of.
How many classes you have?
Yeah, so like if you talk about number of classes that you're registered for. So that's pretty discrete. You can have 1 or 2 or 3 or whatever. So what else? Things you can have none or 1 or 2 of, or 3 or 5. Yeah.
How many siblings or parents?
Perfect. Yeah, number of siblings is a great example. Number of siblings or number of children, things like that. Yeah, that would be considered discrete. Yeah. So you can't record like partial. I mean, you could, but most people wouldn't. So.
Like a half system.
Yeah, you could, I guess. You could have like a half. So normally most people just count them or don't. Yeah. But what else? Anything else? There's lots of them. Things you can only have like none or one or two or 5 or 12 of.
So
Yeah.
would an easier way to describe it be like things that you're able to count, basically?
Sort of. Yeah. Yeah. I think the definition is weird because it's not always only counting values. Like, for example, one example I'll use sometimes it's like if you're talking about the amount of milk you can purchase at the grocery store, right? So it's like you can purchase milk in some weird quantities, but there's a fixed number of package sizes, so you have to walk out. There's only like a certain number of values, but it's not necessarily like you have none or 1 or 2 milks or something. I mean, you can look at it that way, but you could have like a half gallon or a quarter gallon or a whole gallon or an eighth gallon or 1 and an eighth, and that would still be considered discrete. But yeah, that's a good way to think about it. It's like things that you count, sort of. Yeah, counting whole values. Yeah. I don't know. Anything else? You guys kind of get the point, right? Okay. So that's discrete. So that's in contrast to continuous random variables. And again, we're talking about quantitative variables here. So these are variables which can take on infinitely many values. And I'll put in here theoretically, because obviously we have to round or we can only measure so precisely. These are things infinitely many values. Okay. An easier way to think about it is these are things that you could like have like decimal values of, or like fractional values, like things that you could have, that you could have 31.1 or 31.15 or 31.2 of them or something like that. So age, things dealing with time. Anytime we're dealing with like variables that talk about time, we would consider those continuous because technically you can have, if you can measure it precise enough, then you can have infinitely many times. If you looked at like race, people finishing a race or something, even 2 people who finish really close together, probably if you could get accurately enough, there's probably some small minuscule difference between them. So that would be a continuous random variable. So what else might be an example of continuous data? Things you can measure. Yeah.
Money.
Yeah. So typically, even though in transactions we round our money transactions to like the nearest hundredth, it's really more like if you look at the stock market where they're trading constantly, you can measure money beyond the cents. And because the other thing too is the scale is so big that it's like you could have from like $0 to like $1 billion, even if you round to the nearest cent, there's still like a ton of quantities that you could take on.
Length?
Yeah, so length, money, anytime you're measuring length, like heights, so like height is also continuous because probably some of us are probably really close in height, but if you could measure precisely enough, probably none of us are exactly the same height. Right, you could probably find like a minuscule difference between all of us, so it's continuous. So, yeah, age, so time, money, length. I think the one we saw before on the slide before would also be continuous. So temperature would be a continuous random variable. So just stuff like that. Okay, things that can be measured very finely in decimals. So, okay, that makes sense. Okay, and the reason you have to handle these a little bit differently when you're doing analysis. Continuous random variables are actually a little easier to deal with, and we'll focus mostly on continuous random variables as we get through the course. But all right, so just some examples. So if you're looking at the number of heads that you can obtain in 10 flips of a fair coin, what would that be? That would have to be discrete because you can only have what? 10 or 7 or 0 or 1 or 2 or 3 heads, right? It can only be between 0 and 10, and it has to be whole numbers. Okay. Number of miles that you can drive on a tank of gas, miles. Yeah, we consider length continuous. Value of a stock, that's money. That would be continuous. Number of eggs you can purchase at the grocery store. Yeah, I'd probably consider that discrete because you're probably going to buy like a whole number value of eggs. So you get the point. All right? Cool. So data is split two ways. It's split between categorical and quantitative. That's an important distinction. And then within quantitative, we split between discrete and continuous. Yeah.
For the examples, how is the TPM continuous?
Well, it's because what you're actually measuring is the value of a stock. And so this would be the value of the stock. This would be in dollars. And so the actual data measurement you would take is every day you would be reporting a dollar amount. And we consider money a continuous random variable. So, all right. Cool. Not too bad. So, all right. So then we kind of get, there's the big picture of statistics. We understand that we're going to have to go out and collect data from samples. And so you have to kind of decide, okay, well, how are you going to go get your data? And if you're going to design a study, there's multiple ways you can design them. And there's typically split between what we call observational studies and experiments. Experiments, or is it? Did I get that wrong? That's right. Yeah. I don't know. I'm gonna tell you. Yeah, experiments. I think that's right.
Not in English.
Yeah, right. It's not in English. Experiment. It says experiments, not experiments. I don't know. It doesn't matter. So studies tend to have either an observational structure or an experimental structure. What is the key to an experiment? I mean, most of you guys have probably seen experiments before.
We're looking for an outcome.
You're kind of looking for an outcome because what are you going to do in an experiment? Yeah, you're going to actually like control or manipulate things in an experiment. So in an experiment, and we'll talk more about terminology, but an experiment, like treatments or variables, are intentionally introduced or withheld to see their effect. Okay, I'm doing that. I'm going to actually see. I don't know if I started my recording. I did. Sweet. Okay. So experiments are situations where you go out and you actually start messing with stuff. So have any of you guys ever heard, what's an example of an experiment maybe you've read about or heard about? Anything particular? Take psychology class? Anybody here take psychology yet? Or sociology, they probably talk about it. What experiments have you heard of? Pavlov and dogs, right? What did Pavlov do with his dogs?
You ring the bell.
Yeah, he would ring the bell every time he fed them. He was trying to see if he could induce the dogs like salivation by ringing a bell. It turns out you can. So if you feed them every time you ding a bell, eventually all you have to do is ding a bell, and then they just respond as if they're going to get fed, right? They don't even know it, but they just start salivating. They're ready for food. And so there, you're intentionally introducing like the sound and the food to see if you can get some type of result. That's a pretty famous one, right? What else? Other ones? There's like tons. I don't know what all the famous ones are. What's that?
Marshmallow test.
The marshmallow test, yeah, where they look to see if a kid. What's that one? It's like they hold it.
Yeah, if they wait, like I forget the time, but if they wait so long, they'll get an additional number of marshmallows.
Yeah. It's like they put one big one in front of them, and they're like, you can eat this whenever you want, but if you wait 5 minutes, I'm gonna give you another one or something like that. And they look to see if the kids can do that, and then they like track their outcomes over time, and they see like how successful they were in high school and college and in their careers. And they found links between kids who are more patient and like outcomes in life. Okay, which was bad news for me because I'm very impulsive. But I'd definitely be grabbing that marshmallow first. But anyways, yeah. So, but the point is like you're introducing things because you think they're going to have some effect. Okay. Observational, though, in an observational study, in that case, individuals are just observed. And variables are recorded without any intention or without any attempt to influence outcomes. Okay. And these definitions are definitions that I just make up, so they're not like a hard, fast stuff. I don't expect you to like memorize these things word for word because I just make them up. The books, every book would define these differently, so these are kind of just my definitions. So in an observational study, it's like you're not intentionally introducing anything. What you're doing is you're just kind of seeing what's going on. So like an example of that would be like surveys. Okay. Surveys are examples of observational studies. You're not actually going out and introducing treatments or any sort of variables into it. You're just going out and you're seeing what's happening. You know, if you're collecting data off of like going back and looking at medical records or historical records or whatever, you know, then that's just observational studies. Yeah? Okay. So a couple examples that I pulled out of one of my books one time. This one says, there was a study of 22,000 men who received vasectomies, 22,000 who would not. They looked at medical records, and they looked in each group how many developed prostate cancer, and what they found was that men with vasectomies had increased rate of prostate cancer. Not a huge increase, but an increased rate. Is this an observational study or an experiment? Observational. This is observational, okay? It's observational because it's not like they're introducing any sort of treatments or anything like that. This is just they're seeing what has happened based on things that have already happened, right? There's no attempt to influence anything. Yeah? Okay. If you go to the next one, this was a study of 4,500 pregnant women. They were looking at the effect of folic acid supplementation on birth defects. So half of them were given the folic acid, half were given the placebo, and then at the end, they found that those who took the supplement had lower birth defects rates. Again, not a huge effect, but some effect. Is that observational or experimental? Yeah, how do you know it's experimental? They did something, right? They intentionally like gave or withheld something. That's the idea. Okay? All right, make sense? Okay, yeah.
Can you go back to the observational one?
Yeah? Okay.
Sorry, it's because I didn't get to finish reading it all.
Oh, yeah, sorry. Yeah. Yeah, so in this one, they're not actually like, well, this one would be a very unethical experiment because you can't just like give people some fake vasectomies and give people some real vasectomies and like let them loose in the world and see what happens. Like that's a little unethical. You can't really always perform an experiment, right, for people. So, you know.
Like was that one where the guy like was shocking? He was supposedly shocking somebody else.
You're thinking of the Stanford prison experiment. That one was also a bit unethical. That one was they put a guy and they gave him a button. And they would see, they had a fake recording of a guy being shocked on the other end of it when he got questions wrong. And then they would like see how far he would push it. And he would just keep on pushing it, man. It was crazy. Just like, anyways, yeah. Sorry. Yep. Anyways, does that make sense? Difference? Yeah. Okay. So observational studies themselves. So typically there's a few ways that people will perform observational studies. So there's a big difference between observational studies and experiments, in that experiments have a really big advantage over observational studies. Like, what do you think is the advantage of doing an experiment versus an observational study? You have control, right? Were you going to say something else? Basically that? Yeah, like you have control over variables and stuff. Whereas observational studies, you don't get as much control. But you can't always do an experiment. So like this is one of those examples where an experiment's not feasible. Experiments are also expensive and hard, right? So a lot of times studies will do their best to fall back on observationals. And again, there's three ways to do that. So cross-sectional, this is when your data is collected all at once. Okay. These are the terms you'll see in like research papers. They'll do like the methodology, and they'll say, we used a cross-sectional study of blah, blah, blah people taking rah, rah, whatever. And what they're saying in cross-sectional is they're saying that they just took all their data at one time. And so surveys are an example of cross-sectional data. Because I'm going to put a survey out. Even if I leave it open for like a month, I'm basically still getting a snapshot of what's going on right now. A snapshot. All right? So cross-sectional means they were all taken at once. Case control. This is another terminology you'll see used in studies. This is when you're looking back in retrospect at data that's already being collected. So this is retrospective studies looking back at previously collected data.
So like looking at old census.
Yeah. Previously collected data. Yeah, so like for example, yeah, you could look at, if you go back and you look at historical records, like census data, that would be a good example. A lot of times they'll do this with, you'll see this in medical as well. Right, so it's like the data's already been collected in the past. You're just going to go back and you're going to kind of sift through it to see what you can find. That would be case control or retrospective. You'll also see this in what's called, they'll call them meta studies. Anybody know what a meta study is? So a meta study, it's a study of studies. And so what they do is like a lot of people have collected data with a lot of similar information. So like say that you're going back and you want to look at, like we looked at the one with birth defect rates. There's been a ton of studies throughout time on pregnant women, right? And so in each of those studies, they may have all collected very similar data. So what you do is you go back and you sift through those studies and you kind of combine them into sort of like a mega study to see what kind of overarching themes or overarching trends you can see. So those are called meta studies. So they're studies of previously done studies. And then the cohort study, that's where you track your individuals going forward in time. So you start at one point. And then you just see what happens to those people as they go. You're still not introducing any treatments or anything like that. You're just seeing how they go throughout time.
Like the second
What's that?
I think it's like a marshmallow thing.
Yeah, sort of. Yeah, like the marshmallow study where they actually track them over time. And that was part of the data they collected. They collected a lot of other stuff. You'll see this in health studies. There's some really famous ones out there where they try to get people to come back to the doctor at least every 4 years, and they'll record stuff about their medical. And that's how they can sort of calculate risk factors for different types of behaviors like smoking or drinking or whatever. They'll look at people throughout time and see what happens to them throughout time, and also observe their behaviors and stuff like that. So cohort study is actually a pretty decent type of study design. But this also is probably the most difficult one because you actually have to take the time to track people going forward. We do it all the time in college. Probably all of you are in a cohort at CBC and you don't even know it because depending on when you start school, we lump students all into big cohorts and we track to see how they're progressing throughout college, Yeah.
So like symptoms, like medically wise, is that how they found them?
What's that?
Through a cohort, like just symptoms, like headaches or headaches can relate to certain things. Is that how they found those symptoms?
I mean, that's part of it. Yeah, I think typically what will happen is that's a big part of establishing like standard of care is they want to go back and they'll perform studies on historical records and they'll look for certain types of symptoms that are linked to certain types of conditions. And if the link becomes strong enough, then they'll put that sort of in like the checklist of what doctors should go through. Yeah, that's part of it. Mm-hmm. I mean, there's other ways that they find the types of symptoms for different conditions. I don't know, to be honest, entirely how they decide. I don't know that, to be honest. I don't know how the doctor's sort of checklist.
No, but I'm saying like that would be however you say that, cohort, right?
It could be. I mean, you might find that information cohort, but you could find that through case control studies where they're just looking back at medical records. Because they have tons of, I mean, hospitals have massive amounts of data where it's like patient presented and they just mark off a checklist. They presented this symptom A, B, C, D. They list off 7 things. And then eventually if that person gets a diagnosis, then that'll get flagged in their medical records. So you could go back and you could collect everyone who ever got diagnosed with this thing, and then you could go back and see all of the symptoms they ever recorded leading up to that, and you could try to find patterns, you know.
Kind of like plants, you know, like for cohort, you know, like, you know how like plants, you know, like, through time they develop.
Yes. You could, well, that's the thing. The thing is you can design a study in all of these ways for all of those situations. You know, like if you're trying to find something, I mean, you could even do experiments on plants, or if you had to do an observational study, I mean, you could look back at previous data collected about that type of plant. You could. Or you could, like, start with some, you know, seedlings and track them through time and see what, you know what I mean? So that's the thing. You can design a study to answer questions in any of these ways. It just depends on, you know, what's going to be most efficient and useful to you, right? So, you know, a cohort study is a great way to do it, but not everybody has 45 years, you know, to like perform their study. And if the data has already been collected over time, why would you? So, all right. So that's the main ways that we break down observational studies. As far as experiments go, so typically speaking, if you are able to do an experiment, that's a really strong way to try to gather evidence for your hypothesis that you might have. And in an experiment, there's typically what we call explanatory variables and response variables. And I should have had an S there because you could have more than one. So explanatory variables, these are the variables which are introduced or tracked, or accounted for because whoever's running the experiment, I'll say the experimenter, I don't know if it's an E or an A, probably an E, I don't know, it doesn't matter. Because these are the things that the experimenter believes will have an effect on some, what we call the response variable. So these are the things that you think do the affecting, right? And then the response variables, these are the variables that are believed to be affected. So the explanatory variables are the things that you think are doing the affecting. The response variables are the things that you believe are going to be affected. All right. And this actually, I shouldn't necessarily just say this is not just terminology just for experiments. This is actually really, this terminology is just used in studies in general. They're usually typically more well-defined or controlled in experiments, but you can have explanatory variables and response variables in observational experiments as well. Okay. So it's like these are the things we think that if you mess around with, you could change things, and if you mess around with those things, these things are the things we think are going to actually change. Okay. And that's the difference between explanatory and response. All right? So the advantage of experiments, we kind of talked about them a little bit, is that you have a lot of control. And the main thing that you're trying to control for when you do experiments is you're trying to control for lurking variables and confounding variables. And so what a lurking variable, it sounds very ominous, but what a lurking variable is these are variables other than the explanatory variables, which may affect the response, which may have effect. Okay. So it's like they might not be the primary thing of interest in your study, but they're things that you should take into account if you can, because they might have some sort of effect on what you're measuring, even if that's not what you're very interested in. Okay?
Like you were talking on the first day about how many kids at CBC are planning on pursuing later education, but like if they took like a group that just was heading for their associates and wanted to graduate, you know, like a course that you could just finish here.
Yeah.
Change that.
Mm-hmm. Yeah, or like if we think that, like, or if CBC thinks that HDev classes help students complete at a higher rate, that's an example of like an explanatory and a response variable. But there's tons of other variables that affect completion rates that have nothing to do with HDev that you may want to take into account in your study. Yeah, exactly. It's just something that's kind of lurking in the background that you probably want to take account of, and you can do that in experiments much more easily. And what happens is if you don't do a very good job of accounting for lurking variables, what happens is you may end up with confounding. And confounding happens when the effect of two or more variables can't be separated. And this is something that you also run into if you're doing an observational study that you can control for in an experiment. Okay. And so confounding happens when like too many things change at once and you can't necessarily tell which caused what. So it's like if let's say that like at CBC, you know, like we changed all of our, let's say like we changed all of our math courses, then and in the same year we started making everyone take like HDev classes, and in the same year we decided to double the size of our like tutoring services or something like that. And then maybe at the end of those 2 or 3 years we find that like graduation rates went up. Okay. Well, the problem is how do you know which of those 3 variables actually had an effect on the graduation rates? You know, they're all confounded because you changed them all at once, and you can't actually tell which one caused the outcome. But in a more well-designed experiment, you might be able to like control for some of that stuff. Like if you could get multiple colleges in there, and maybe you could just do each of the programs at one of the college, like one thing at each college, and then maybe one college gets a combination of 2 of those things, and another college gets another, right? And you try to match up all the different combos of those things so that you can observe their effect and see if some of them are more effective than others. That's the idea. So, and the main advantage of experiments is the difference between what we call causation and correlation. So, in an experiment, that actually allows you to declare causation. If you do a good job controlling for variables. So what's the difference between causation and correlation? Do you guys know? Or have you ever heard a discussion about that? Any experience with those 2 words? Maybe?
What?
Causation and correlation? Does anybody know the difference between those?
What caused it and what's the similarities between the 2?
Yeah, so like causation, this is like when one variable causes another to change. So in causation, it's like if you do this, this will happen, and it's because you did this. There's a causal relationship. But in correlation just means that there's a pattern that how do I want to say this? There's like it's a pattern, you know, where one variable changes as another does. Okay. So the like one, and we'll talk more about correlation and causation later when we get into like two variable analysis. But like one famous example is that like if you look at a plot that shows the relationship between people getting Lyme disease and people buying ice cream, it turns out that ice cream sales are higher when the number of Lyme disease cases are also higher. So does that necessarily mean that, say, like ice cream sales are causing Lyme disease to go up, or that Lyme disease is causing ice cream sales to go up? Is that the case? It's not causal, but why is there a relationship between those two things? Anybody want to guess?
More people are sick and eating ice cream?
Well, that would be almost a causal relationship, though. It's like, oh, people get sick with Lyme disease and they eat ice cream. But it's not quite. It's actually something more simple than that. So, how do you get Lyme? Anybody know how you get Lyme disease? Maybe that would help. How do you get Lyme disease? That would no. That would be. I don't know what that would be, but Lyme disease you get from ticks. So Lyme disease you can only get from ticks. So they have to be ticks that carry Lyme.
But don't like mosquitoes and like ticks, aren't they attracted to like sugary blood and stuff?
I don't know. But mosquitoes don't carry Lyme. I know that. But only ticks carry Lyme. Yeah. So when are people getting ticks? They're getting ticks when they're outside and ticks are active. Well, when are ticks outside and active, and when are people outside and active? When it's warmer. And when are people buying more ice cream? When it's warmer, right? So there isn't a causal relationship between Lyme disease and ice cream sales, right? There's no causation there. But if you were to compare Lyme disease reports and ice cream sales per month, there'd be a super strong pattern. Okay? There's a really big connection between these two pattern, but it's not causal. And in observational experiments, because you don't have any control over lurking variables and you haven't taken into account, you're not able to take everything into account, you can't declare causation from an observational study. If you want to go on and declare causation, then you really need to perform an experiment in order to decide whether that's the case. So like the one we saw earlier where it was like there was an observational study where they noticed that men with vasectomies had a slightly higher prostate cancer rate. You can't declare causation from this really because you don't really have control over any other lurking variables that might affect people's developing prostate cancer, right? So it's just an observational study. But experiments do allow you to declare causation, and that's one of the advantages of experiments. Okay. So when you do a well-designed experiment and you change this and this happened, you can be pretty confident that the reason this happened is because you did this. That's the advantage. Okay. All right. So like this was an example of experiment that I put up before. So it's the pregnant women, folic acid supplement. Half were given a placebo, and at the end of the experiment, they found that the ones who took the supplement had lower birth defects rates. What's the explanatory variable here? Yeah, so that's the thing that you think is doing the explaining or the affecting. So the explanatory variable would be folic acid. That's what they think is going to have an effect. What would be the response variable here? So it would be your birth defect rate. Now, are there any lurking variables in the study? A lot, yeah. Because, for example, like if you look at genetics or you look at family history, right, that could have a really big effect on birth defect rates, right? Because remember, what lurking variables are variables other than that might affect that. So what else? There's lots of them. What else could it be?
Like what the women did while they were pregnant?
Yes, things like lifestyle, right? Lifestyle could have an effect.
Accidents.
Yeah, accidents would probably. That would be a really unique situation. But yes, definitely. Like if there was any sort of like traumatic injury or something like that, for sure.
Like
Age.
sample that you chose, like the people who chose?
Well, hopefully not, and that we're going to talk more about sampling probably tomorrow. But ideally, you would pick your sample in a way that's representative, of the population at large.
Age.
But I think age is one of those. So age has an effect on birth defect rates. There's probably more too, I'm guessing.
What if, I honestly don't even know what folic acid is, but like what if...
It's like a B vitamin. I think it's B6 or B12. Anybody know? It's a B vitamin.
What if the woman already had more folic acid than normal?
Yeah, right. So I think that I would probably call that under lifestyle. Like that would have to do a lot with their diet, So depending on what they eat or don't eat, depending on how much how healthy they are, that may have a big effect on it. Yeah, for sure. Because you might be giving someone a placebo, but then they might be getting a lot of folic acid through their diet, and you wouldn't know that. So that'd be a lurking variable. Yeah, diet. I think if you put that under lifestyle, like diet, that'd be in there. Anything else? There's lots of them.
What if their bodies responded to it differently?
Yeah, I mean it could be actually allergies or something. Yeah, that would be weird. I don't know.
Can you be allergic to vitamins?
I bet you could.
You can, yeah, actually you can be allergic to synthetic folic acid because folic acid is a synthetic version, I think, of B6. It's not the natural occurring, because I think the natural occurring version is folate, which is different than folic acid. Is that true?
That's right.
Right? And there are genetic conditions which can cause people to not be able to absorb folic acid, but they can absorb folate. Which is weird, but it can happen.
So that would just go with genetics.
Yeah, I would probably put that under genetics because it's like a genetic thing. Yeah. Yeah.
It's huge. The number is huge. It's like 1 in 5 cannot absorb at some point in their life.
Yes. Yeah, and it's weird because a lot of people thought that was some just goofy theory, but there's a lot of medical studies coming out now that are confirming that you can't absorb. Or they can't absorb folic acid correctly. And so I think, do you remember what the condition is called? Because I think, if I remember, this is not really relevant to the course. Yeah, I think I might be wrong, but I think it's MTFHR is the name of the condition. But you could look that up. Anyways, it's not really that relevant to the course. But that would be an example of a genetic condition that would definitely affect the study. Yeah, I think you guys get the point, right? Those are the lurking variables. And these are the types of things that you could try to take control of or take into account if you did an experiment, because you could group people by genetic or family history, before you start the experiment. You could group people by their age before you start the experiment. And you could try to kind of sort people out a little bit so you can get better results or more detailed, informative results. So, okay? All right. I think that's a good enough place to stop. So tomorrow, what we'll talk about, because you were asking about how it matters who you talk to, and it definitely does. So we're going to get into a conversation about sampling and good and bad ways to collect samples. So, and then
Should you take the quiz tonight? Kind of like.
I think you would.
You can retake it, right?
Yeah, you can retake it tomorrow. So you could probably take your first attempt tonight. I think we've covered. I think maybe sampling's the last part of it, but yeah.
Do you have just a quick example of confounding variables? I feel like I don't get it.
Yeah, it'd be okay, so let's say that I was going to just see if certain things would affect how students take tests. Mm-hmm. And let's say I decide half of the class is going to take their tests in here normal, and half of the class is going to take the test over in the courtyard, with all the trees, over in the courtyard, and I'm going to give them all cookies to eat while they take the test, right? And then let's say that the people over in the courtyard end up doing better than the people in the classroom. Well, the problem is because I didn't design my experiment very well, I don't know if it's the courtyard or if it's the cookies that made them do better.
Okay.
Yeah.
Thank you.
So, for the quiz, if you take the first quiz, I
Yes.
still haven't taken it, and you do good on it, do you just take that score and then?
You can.
But then, if you do both, you average them
Mhm.
together. Is that okay? And so can we take the first quiz tonight, or do you?
You could, yeah.
Or-
I think there might be a couple things we haven't quite got to, but it's not. I don't think there's anything in there that's like crazy.
Okay.
So you could try your first attempt if you want, or you can wait till tomorrow. It's up to you.
Okay.
Yeah.
What kind of work should I be doing at home for this class?
So mostly I'm gonna stop this real quick. Stop.